So we chose this equation here to use because it has the desired variable and everything else we know. In this equation, it has the desired variable. We know the t, but we don't have the displacement explicitly in the story problem. Yes, we could figure it out if we wanted to, but that's doing some calculations in our head, and we don't really want to do that if we can help it. So it'd be best not to use that. Okay, so now we substitute it in our numbers. We're looking for the average velocity, so that stays letters. The final location is 1,000. The initial location is 200. And the time is 40 seconds. First do the top. We get 800. And then divide 800 by 40, and I believe you're going to get 20. And it's a velocity. We're working with meters and with seconds. So you put the plain old unit of length on top and a unit of time on the bottom. Number 11, try this one on your own and then turn to your neighbor and see if they get the same thing. And then watch the video and see if you get the same thing as me. It says here, find the average velocity. Okay, here we go. Find the average velocity if a car takes 8 seconds to move from a spot 30 feet on the left side of the origin from a spot 10 yards on the right side. Now, this can be kind of tricky if you don't read it carefully, so make sure that you've read it correctly. It takes 8 seconds, that's a time, to move to a spot. So this to a spot, this 30 feet, that is where it ends up. That is the final location. It's 30 feet from the left side of the origin. It moves from a spot 10 yards on the right side of the origin. It moves from this location. So that means that this is the initial starting location, x sub I. Okay, so if you messed up on that, and believe me, I did mess up on this earlier myself. If you messed up on it, go ahead, go back and rechange those variables. Make sure you have the positives and negatives correct, and then start the video again. Okay, let's see here. We have just simply a spot that things are measured from. So I'm going to have that spot, and that's the origin, positive that way. We're moving from a spot 10 yards on the right side. So here's my car. That is x sub I is 10 yards. It's moving to a spot 30 feet on the left side. So here's a spot. The final location is 30 feet. And so it's moving this way. And the time for that movement is 8 seconds. Okay, so that's everything that I know. That's step number 2. Number 3, desired variable. We want to find the average velocity. Step number 4, are the units compatible? We have feet here and we have yards there, so no, they're not compatible. Let's change this 30 feet to be 10 yards. I could have changed the 10 yards to be 30 feet, doesn't matter. Okay, everything else, we have seconds, yeah, everything else is okay. Anything negative? Yes, over here, this is on the left side of the origin, so that needs to be a negative 10 yards. I'm going to scribble out the 30 feet because I'm not going to use that anymore. Time is always positive. The initial is on the right-hand side, positive. Okay, so that's step number 5. Step number 6, find the raw equation. So I'm going to use my new derived equation, x sub f minus x sub I divided by t, and then put in my numbers. Average velocity, the final location, negative 10 yards. the minus the initial location, 10 yards, divided by the time, 8 seconds. That's going to be negative 20 yards divided by 8 seconds. Divide that out, you get negative 2.5 yards per second. That means that for every second that goes by, the object has moved 2.5 yards in the negative left direction. So, how do you know which equation to use? Number one, it has to have the desired variable. Step number two, you need to know all the other variables. Go ahead and read future assessment, and number four, take it home, and then we're done.